Area-52. I'm sure you folks have all seen it. I just want to walk through. Oh, I have my Zoom thing in the way. Maybe I can move this. It's in the way of the controls. What do I drag this? Oh yeah, here we go. If I just go to the next section, yeah. So here we have more of like a normal course section in Area-52, and I just want to sort of draw your attention to the different parts that we have. So on the top left, you're always going to have it has this little background. Yeah. See, there's like a very light background. This area with the background in upper left is the storyline. So this is just some narrative component to kind of help situate you and let you know what we're all building together. And then underneath that, we have the educational content, which is the stuff that you're trying to learn or that is relevant to what you're learning and what you need to complete in the exercise. And if we keep scrolling down past the educational content, we get to the exercise. Oh, didn't mean to close that. What just happened? There we go. Sorry about that. Yeah, we get to the exercise itself, and then the exercise is completed in the right. I'm sure that's probably not anything new for anyone. Something that may or may not be confusing is that when we submit an answer here, and maybe I'll just put an error in so we can submit. So what we get here is a diff. We don't have any Rust compiler, which is compiling this code. The Area-52 expects an answer in a specific format. So I just want to mention this because you could have the right answer from a Rust perspective, but have it not compile. Well, sorry, not complete the step rather. So of course, I haven't changed the code at all. You see, I put a new line character on line 4 here. If I try to submit this answer, it's going to say that it's not correct. Because it is just a diff, it's not a compiler. It really expects a very specific answer. When we give it that very specific answer, and of course it will tell you exactly what the specific answer you need is. Once you provide it with that, you're able to complete the exercise. I'm just going to go back to the entry level exercise. Nothing too tricky here. I just want to go over compiling Rust for a second because as we've just discussed, we're looking at diffs when we're in Area 2. We're not looking at a compiler error. So in case it's not clear, when I say diff, I mean like a short form of the word difference. We get the difference between what is correct, or what Area-52 rather thinks of being correct, versus what you wrote. So it's just going to tell you what is different between those two things. So this is the completed exercise from lesson 1. And it's just a quick spin-off of the actual Hello World example from Rust itself. So how do we compile it? One thing that we could do is we could take this code and we could put it into the Rust playground. Now here is the Rust playground. Kind of saves whatever you had in there last. So you see that I was doing something. I'm trying to make this a bit larger for everyone. I was just checking some typings for CoinStruct. But let's just get rid of this one and put our answer there. And of course, we could compile our code this way. We didn't have to install anything when we run it. Seems to be taking a while, but at the end of it, we get our 2 printouts, which is, what we wanted. But what is the limitation of compiling our code with an online compiler like this? Well, the limitation, of course, is that we cannot use external crates. What we have access to from the Rust playground here is just Rust standard library. So if we, fast forward again to another lesson, you see already we need to bring in CosmWasm standard library. And if we try to do something like that in the Rust playground, it's no longer going to work. I'm expecting, I haven't tried this. I'm expecting that the compiler is not going to proceed past the first line. Normally, if we wrote code like this, and we checked it with our local compiler on our computer, if we, in our cargo.toml, which is where we define our dependencies, if we imported CosmWasm standard library, normally we expect that we are able to use it. So if we put this exact code in and we had exposed the standard library for CosmWasm in our cargo.toml as a dependency, this code would pass. It would output what we want, but of course we would get a warning. The reason why we would get a warning is because we actually haven't used this dependency in our program. However, but because we're on this online compiler and we don't have access to external crates, my expectation when I click run is that it's not going to pass this first line because we shouldn't have access to that. Yes, unresolved import. So that is what I wanted to explain about using Rust Playground. You're not going to be able to do it for very much. It's helpful when you want to check like a type or something, but for most, like 99.99% of the time, we're actually going to have to do stuff on our computers. So, what would it look like to do this on our computer? Before we dive into the CosmWasm part of it. So let's just bring up a terminal for my computer. And once again, shout at me if this isn't large enough for everyone to read. It looks kind of large for me. So what I'm going to do is I'm going to create a new Rust program from scratch. And I can do that because I have Rust installed. Yes, so Rust C stands for Rust compiler. You see that I'm on version 1.64.0, and this is the date that it was installed. And then because I also have cargo, which is dependency manager for Rust, I can use cargo commands. You will get access to all these things if you install Rust, using the normal way of installing it, which is with RustUp. So when you install RustUp, you're going to get cargo, you're going to get Rust C compiler as well. So I'm just going to assume everyone is all good with that and you have these tools installed. And create a brand new Rust project. And the way that we can do that is with the cargo new command. After the cargo new command, you can serve the name, and we will call this, the name of our program will be Hello Area-52. So here we go. You can see it created a binary application. If we look at what's in our directory, we now have this directory here. If we look at what's inside of that, we see we have our cargo file and we have our source directory. And in the source directory, we have a single file, which is the main RS of our program. If we look at that, the contents of that file right now, we have the Rust example, which has been modified by Area-52 with some small changes. So this thing keeps getting in the way. I don't know if you can see that. So if we should probably build it first. The command to build, we use cargo build, and it finished. We use cargo test. It's going to build it again, but there are no tests to run, so it's surely going to pass. It ran 0 tests with a test result of OK. good result to have when you have 0 tests included. And we can also run it with the command cargo run. If we run it, the expectation here is that it's going to print the text hello world. Boom. So we got that. And now we can just take this code and put it into main RS. And then we'll have compiled the first lesson from Area-52 on our computers as a standalone program. So let me just go into the file. Luckily, it's not a very long file, so not difficult here to delete it all. Just put in the new contents. We are going to have to build it again, which is pretty quick. It's a very small program. Once we do that, we can run it. And as you see, we have the expected output. The same output which we got from the playground, but we did it in a much cooler way on our own computer with code and a compiler that is fully under our system's control. So that is that section. The question now is how do we start taking all of this stuff that we're building with Area-52 and how do we start running that code on our computers? And more importantly, how do we start modifying it to make our own cool programs? Like how do we take some of the concepts from Area-52 and build our own software with it? I'm just going to go back to here and get out of the directory where we did our little hello world example. And in this folder here, what I've done in that folder is I've just ahead of time, I've gone and cloned the GitHub project for the courses. So that should be in, everyone should have gotten this document. It has all of the links that are relevant to today. And if someone could, from the team here, could put that out into the chat right now, if the people don't have access to this document. Otherwise, what everyone can do is open the GitHub link, which is under this section here, like kind of right in the middle, which brings you to this GitHub, and you can clone that. And then you'll be able to follow along with what I'm doing right now. So in that directory, if I look at the remote, you're going to see that the URL is the same. So I'm on definitely on this GitHub right now. So a little bit about navigating this is that we only have one course right now, so here is all the code for that. But something that may be a little bit confusing is that these are actually 3 separate Rust projects. When we did cargo new project name a moment ago when we created our local program, compiled and ran it, we have 3 of those. And the last code that we were working with, if for those of you that have gotten all the way to the end of the first course, the last code that we were working on was the Ocean project. So just a little bit about what these 3 projects are, is that, well, the Universe project, that is just like the universe of Area-52. There's really not a lot of code in there. And the code that is in that project, it's types and helpers. So this project is being built in a library, it's being included in Potion, and it's being included in Portal. And it's just giving us the models and schema for things like the Sapiens the level of sapience of the different characters who are going to step through the portal, and some other helpful types. There's no contract code in universe. So that is the important thing to remember that sets it apart from Potion and Portal, which are smart contract projects. So what are these two smart contract projects? Well, of course, the Portal is the main project that we're building. This is the jump ring. So the idea for the jump ring, and we'll dive a little more in depth in that in a second. The idea for the jump ring is that we have something which represents ourselves. And I don't want to ruin the mystery too much by telling you like exactly about what that's going to be. But you can imagine that we have some sort of token to represent ourselves. And once we have that token, it doesn't exist right now, and probably will be a fourth project, in our Area-52, ever-growing list of projects that create this universe. We have these identity tokens, and then we'll be able to teleport them to other planets, other blockchains using IBC. This is all stuff which is coming later, which hopefully everyone here will be able to help me build. And of course, a big part of today's lesson to get everyone situated is to give you the tools so that you can help me build. So the portal is the jump ring, but what is the potion? The potion is the imbiber elixir that you're drinking from the beakers. It has an effect on your DNA, which in Area-52, if you've gotten that far, is called cyberdizing the traveler. And what cyberdizing the traveler does is it takes a string which is used to represent that traveler's DNA, and it makes it cyborg DNA. So it transforms the DNA of the caller into cyborg DNA to prepare them for travel so that they can make it through to the other side without being turned into molecular goo. So we've talked about what they are. Let's just go into one of them for a second. Today, we're going to be looking at Portal. We're going to be looking at Potion. We're not really going to be looking at Universe. But first, I'm going to go into Portal. Now, this step should go fast for me because I've built it already. But it might not go as fast for you folks if you're building it for the first time. It could take a few minutes. If I do cargo build, as you can see, it finished in less than a second. If I do cargo test, unfortunately, there are no tests to run. So something that we're all going to have to try to be building out in the next few sessions is getting more tests in here, because I feel like the project is going to start making a lot more sense if we start including tests. I've just begun to do that work. As you see, if I go and I build the portion, which the potion contract, which is the imbiber to cyberdize ourselves for travel. If I build it, once again, it's really quick. But this time, if I do cargo test, there is one test. So I've written one test for this so far. It's in the execute functions folder, and it is part of stepping through the jump ring. And what it tests is that it is enforcing a specific payment. So now I think what you'll want to do is, I assume you've cloned the project. So you can bring up these two files, or you can just open them from these links here. We do that. Should highlight the lines, which we want to look at here. So in the portal contract, portal travel is conducted through this function, which is called initiate jump ring travel. Now, the difficulty right now is that this is an unfinished function. This is kind of like some of the next step that we're going to work on together. Is all of this function is doing right now is returning us a result, a Rust result from CosmWasm standard library, just a default OK. So our initiate jump ring travel function right now, it's not really doing anything. The other function, which is relevant for stepping through the jump ring, is actually in the portal contract. I'm sorry, in the potion contract, and that is the one that we were working on in the final lessons. So you can see that this is stepped through jump ring in the potion contract. You see we're in the context of potion right now. And when we step through this one, what we do is we call the other one. And we call jump ring travel. And to spare you a long explanation, jump ring travel is going to end up calling initiate jump ring travel. And if you made it to the end of the first lesson, or sorry, the first course rather, this code should be familiar with you. So just to bring you up to speed, the last thing that we did was we required a payment for stepping through the portal. And then the other thing that we did, that I did more recently, which is not covered in the course material, is that I created a test just to make sure that the sending of the payment and the checker for enforcing the payment, that yes, when we call check sent required payment, it is in fact checking that the funds that were sent matches the requirement or is greater than it. So a user calling step through jump ring, they will pass to the next step, which will actually initiate the jump ring travel. Provided they've sent the payment, we will call the other contract. There's just a quick question now for the audience. Does anyone see a problem with the way things are set up right now? Because I see a problem, and that is exactly what we're going to try to fix today. So any guesses? You can type them into the chat. We'll just leave us 1 minute to figure that out. Any brave souls? Oh, I guess I should look at the chat. No takers? Okay, we'll give you another 30-second. I smell smoke. Our brains must be grinding hard gears. Okay. Right. So the problem, as I see it right now, is that we are requiring them to send payments in the potion contract. And right now, there is nothing to stop a caller from calling jump ring travel, which will, once again, jump ring travel will initiate the jump ring travel in this function here. So a user who wants to travel through the jump ring, they could avoid having to pay for it. How would they avoid having to pay for it? They could just call this directly. They could go to the portal contract and teleport from the portal contract without calling step through jump ring in the potion contract. So now that I've explained that to you, what do you guys think we need to do? What do we got to build together today to stop that from happening? So once again, the problem is that a user could call step through jump ring on the portal contract, and that would avoid them having to pay. It would also, mind you, avoid the check for sapience level and the check for cybernetist. But once again, a smart individual might just go to the potion contract, get themselves cybernized at the DNA level, and make sure they have the proper sapience, and then leave the context of the potion contract, and then just go right away to the portal contract and initiate their jump ring travel from there. So yeah, what do we got to do with our portal contract to make sure that they're paying and that the checks are met that we set up in the potion? Just give you a sec, guys. Any guesses? Well, quiet bunch. Just let this simmer for a second. Let you feel that awkwardness. It's okay. All right. I will explain the mystery. So what we need to do, what we're trying to do, is make sure when they're calling the jump ring, that they are coming to jump ring travel through this context. And this context, once again, is coming from the potion. And it might be tempting to be like, oh, why don't we just put all this stuff in here, in the portal contract? Move it from the potion contract into the portal contract. Very tempting, but I don't think it's the best way to do it. So I think the best way to do it, we have all this stuff for cross-contract calling, right? We have the potion contract. It's set up already to call the portal contract. So what we're going to do in the potion or the portal contract is add a few things here to our jump ring, initiate jump ring travel. And also we're going to create a new function too. Now what we're going to do is we're going to make sure that the person who calls this function is the portal contract. Sorry, the potion contract. I keep potion, portal, I keep getting those two confused, and that's clearly not helpful right now. Potion, portal, they're way too close. I should have thought about that before we called them potion and portal. Anyways, yeah, so we are in the portal context, and we need to add a couple things. So the first thing that we're going to add is we're going to add a check to make sure that the individual who calls this function, we look at like one of our other functions, right? We have checks. We make sure that the sender is the owner of the contract. So the only person who can set minimum sapience in the portal contract is the owner of the contract, right? We set the state.owner at instantiation. We're going to need to do the same thing for the potion contract. So instead of info.sender equal to state.owner, what we're going to have in here is we're going to have info.sender equal to state.potion. Okay, so and then the other thing that we need to do is we need to create a similar function to this one. This function allows the owner to set the minimum sapience required for a traveler to journey through the jump ring. we're going to need to do a similar thing. We are going to need to give the owner of the contract the ability to update the potion contract address, just in case it ever changes or there's a upgrade made, or yeah, probably a good idea. We're going to declare it. We're going to declare the address for the potion contract at instantiation, but I just feel like we should also give them the ability to update that address later to a different contract address. Maybe someone makes a better version. Yep, so let's go ahead and do it. So this is, once again, this is the last code that we're working on. This is in Potion. Now we are moving into the portal. So the files that we're going to need to change are execute functions, the contract, the message file, and the state file. I think I'm going to try to work like a little bit backwards. So let's just give ourselves the ability right now to actually have something in our state which refers to portal. As you can see, it's an address, just like owner, which means we don't need to import any other type. We have address already here. So save one file, that's done. And then we're probably gonna, well, let's go into the message file and let's look at what we need to change there. So we want to have this available as something that we're setting at instantiation time, right? So we're going to need to add this as a parameter at instantiation. So kind of just same thing here. You're going to add a public property for that. We're also, I think, going to need to have something so that we can call it, right? We're going to need to make our own execute function, right? Which we can call. So we'll make that there. We're going to make set potion contract and give it an argument potion of an address type. Excuse me. And what this is going to do is it's going to allow us to have a message type so that we can have an execute message for setting the potion contract. And what that means is, once we expose that in our contract file, which we're going to do in a second, we'll have a way for the owner of the contract, the portal contract, to update the address of the portal. Okay, so those are our messages. Let's go ahead and actually write the functions before we enable them in our contract. So let's see. So we're going to make our changes to initiating the jump ring travel first. So we're going to need to use deps because we know we have some storage stuff. So I'm going to remove the prefixes. Prefixes, when you see them like this, it's a way to ignore warnings from the compiler that you haven't used the variable. So we're going to definitely use these two variables so I can remove the underscore prefix. Okay, so let's load our state. We're just going to load state the same way as we did in previously when we were setting minimum sapience. Let's go ahead and load the state. And then we're going to do something similar to this. But yes, needs to be state.potion, right? We look at state, we have owner, we have potion. Yeah, so we're going to change that to state.potion. And this is the crux of what we're trying to do here, right? So if the person calling this function in the portal contract happens to not be the potion contract, then we return an error. Otherwise, we can go ahead and process it. Now, we're not doing that processing. We're just returning an okay result right now, but that is what we were doing previously as well. The difference in our function now is that we are enforcing that the person calling the jump ring travel is indeed the potion contract. So it can no longer be called by just anybody. Only person who can operate the jump ring travel from the portal's context now is the potion contract. So that part of it is good. I think we're done for that part of it. I'm going to try to get through the next stuff quickly, but we're almost done, folks. I want to leave some time for questions. But we need to do one more function, right? So we need to do the ability for the owner of the portal to come later and update the potion's address in case they ever need to update that contract address. And I think that it's going to be pretty similar to this function that we already had, right? Let's give it a better name. We'll call this one set potion contract. Doesn't take a Sapient scale, obviously. It's going to take potion as its argument. Because that's what we want to update, right? And then the other things are just the stuff you have in regular execute functions. We have the message info and access to our dependencies here. This looks good. Just thinking this looks good. This is not good. Yeah, so what we save in state is potion. We no longer have the two variable, we have the potion variable. So yeah, so okay. So in the state struct, we have our potion, and that gives us the ability to set state.potion equal to the potion, which is the incoming argument here. What about this one? Is that? Yeah, that looks right to me. We have config. And then we save the whole state struct. Yeah, that's right. That is going to work, in my opinion. Cool. So we're almost done now. I think the only thing we have to do is set up everything we need in the contract, right? So there are a few places in the contract we're going to need to change. I know we're going to need to change execute. Oh, but we're also going to need to import our new function, right? Where is execute functions? Oh yeah, here. So we have set minimum sapience. We need our new one. And what do we call it? Set motion contract, I think. Is that right? That's what we called it. Looks like it. Just to be extra sure. Yep, so we have imported that from our crate here. Now I think we're going to need to change execute, right? And here's the way that it's working. So we saw jump ring travel, right? Which is what we were calling from the WASM on this one. You can see what we call jump ring travel, right? So I didn't make this super explicit before. And what does jump ring travel do? It calls initiate jump ring, which is the one that we were changing. Just so that's clear for everyone. Of course, yeah, we're going to need to make our new one here. We need to expose the ability for our contract owner to update the potion address. We're also going to set it at instantiation. but just so they can change it later, that part of it's done. I think the last thing that we're going to need to do. Did I miss anything? Oh, I think this is correct. But we're also going to need to change our instantiate as well. Because we've added a new parameter here, right? Yeah. So I think we just need to add that parameter, and then I think we're done. We can try to compile it. We don't have any tests. We haven't verified the correctness of that. This should work. And I just want to make sure I have these in the right order. So if we look at state, yeah, the second, we added it after owner. Go back to contract, we added it after owner. Yeah, so that seems correct for me. Just verify I saved all the files. I do. As you can see, the files are in a modified state. If I look at my terminal and I do get status, it should show you all of the files which I changed. Now it's time for us to cross our fingers. We can try to build this. Oh no, what did I do? Oh, I see, it's just a warning. Yeah, so because I copied it, we just. Yeah. See, we created a mutable. As you can see, like, it's just a warning, right? Like the code did pass, but we created a mutable because we made it clear. But we actually don't change it, so we can actually just remove this mutable. There we go. So if I compile it again, should work now, right? Yeah, no more warnings. And if we do our tests again, it's going to build it again. We don't have any tests for the new code that we added, but the new code that we added is compiling and it is expected for us to work. So maybe in our next session, we can actually go and write another test and test the correctness of all the new code which we just added. And the thing that we would want to test is we need to set up a test where we have our environment with two contracts. So a multi-test environment, which we'll do with this CosmWasm. Oh, if I could type. I think it's called multi-test. Yeah, so CW multi-test. So we can create a multi-test next week. And then what we'll be doing with the multi-test is we'll have our test will instantiate two contracts and have them talk to each other. So we'll instantiate our portal contract, we'll instantiate our potion contract. Once we have those two contract instances, we'll be able to write a test to check that when we call initiate jump ring travel, it can only be called from the potion. So that's it for me. If y'all have questions, now is the time. Does seem like we lost a few people. Any questions at all? Doesn't have to be about the workshop. Oh yeah, I can show you that. Oh, and Ollie, the other thing that you can do is I've actually pushed this code, but it's in a different branch. So what I'll do is I will share that. So here is a diff for you, Ollie. This is going to show all of the changes, and then I'll actually give you a link to the actual code as well.
Oh, sorry, Drew, could you repost what you wanted to share with Ollie to everyone? Because it was sent on in the post.
Oh, how do I change? Okay. Everyone.
Yeah,
Yeah.
everyone.
Okay.
Yeah.
Sorry, Ollie. This is a diff. Hopefully that is publicly visible. I think it is. It's just a draft, but that will show you all the changes that I made today. But then actually just to give you a reference to the file itself, let me get that. Okay. So this is the file that you asked for. That's the execute functions. So yeah, that branch isn't merged, but all the changes that I was showing today, kind of made live in real time, they should be the same as that. Sergey, regarding books on smart contract building, like I'm sure there's lots of them, but I'm not sure there's anything in book format for CosmWasm specifically. Most of the books that I've seen are Ethereum Solidity based. Well, a few of the concepts carry over, like it's really different. So not sure what to tell you. There's a video series that the CosmWasm folks have made themselves. And there is obviously Area-52. These are like two of the best learning resources, probably. I'd like to make a book. I spent a lot of time writing story. I think a book could be beautiful. There are a lot of cool illustrations in Area-52. It's a project I really enjoy working on. Is there any questions I missed? Saw something about, oh yeah. Any tips for coders who are used to Rust but not yet comfortable with it? Yeah, the big tip from me is that to test everything, always write tests. And as you can see, we're going to focus on that more next week. But writing tests is really difficult. It's very verbose. So I obviously am doing a lot of CosmWasm development in my day-to-day. And I can tell you that my tests, the amount of code is longer for the tests than the actual code that the tests are checking. So I spend more time writing tests than writing code from a certain perspective. But like having everything, like having a test for everything that you want your application to do, that you want your smart contract to do, is like the best approach. And actually, like it makes things really, really complicated right now in Area-52 that there are not tests for everything. There's only one test, and that is for the enforcement of payment. And that is just something that I wrote recently. So Area-52 needs tests. We're going to build best practice for dApps, obviously tests, once again. And I think that, you know, dApps is a bit of like an open-ended thing, right? Because they also include the front end, as well as the smart contract piece. So for the front end, I would say that like one best practice that you may want to consider in your development workflow is that support multiple wallets. Like not everyone is using Kepler, right? There is several other wallets. For example, Falcon is another wallet. I think in the future, like somebody is going to hopefully do the work of making like a library for JavaScript or TypeScript, which allows you to kind of just incorporate that library, and then you'll be able to support different wallets. But right now it's really like up for us to do that work. So if you want to support multiple wallets, you're going to have to kind of do that yourself. But I would put that as a best practice. You should support other wallets. And then from the smart contract perspective, like obviously tests, as I've been harping on and on about, like that is like the gold standard of best practice from my perspective. But another best practice, which is like not always considered, is that you should think about when is the best time to have your code also be a standard library in addition to being a contract. So in order to release your code in a format that works both as a contract, which is something that you can store on a network, add a code ID, and then instantiate it. In addition to doing that, you may also wish to build them as standard libraries, or sorry, not standard libraries, as their own library. The reason why you would want to do that, and you will notice if you look at Area-52, all three of the projects, these are Portal, Potion, and Universe. All three of those projects are built as libraries in addition to being contracts. And the reason for doing that is that other projects, so say I'm working on like a token project or a DeFi project, I can incorporate Area-52 into my project by importing it. They are importable as a library. So if you want your project to be something else that maybe other projects will use, you should really consider also doing the small amount of extra work so that it's built not only as a contract, but a library. So if I want to use your project, of course, I could incorporate it into my project through a WASM call, like the one that we were just looking at in the Potion contract. You know, your contract calls another contract. So that's cool. That works. It costs more gas. Slightly more computationally complex. But if you have your project exposed as well, like on GitHub somewhere as a library, or even resolvable as a crate on crates.io, it's like way more user-friendly for other devs to build off of your code and to include references to your code in their project. So that's a best practice, which maybe goes a little more under the hood. Any other questions that I missed? I'm just trying to scroll up. Any other questions, folks? Guess we're 5 minutes over time. I have nothing pressing. I can stay here for a few minutes if there's more questions. Oh, I think there is one question that I missed. Let me just find it. Tips for people that are not yet comfortable with Rust. Yeah, I mean, this is obviously like a big hurdle for everyone, myself included. You know, professionally, I've been working with Rust for like just a bit less than a year and a half. I wasn't totally new to Rust when I started working on it professionally. So, you know, I had like a bunch of Rust experience, but I felt very uncomfortable with it. So the Rust book is really, really well written. And I know it sounds like an awful thing to do, but like reading the entire Rust book is not like super long, or like at least reading the, you know, the first 5 chapters of the Rust book is like really good in terms of like growing your foundation. And then the other thing, if you're not like totally comfortable with Rust, that you should do is build a bunch of small projects. Like coming right into like a full scale like CosmWasm, you know, intercontract calling ecosystem is maybe like setting the bar a bit too high the first time up to the plate. And I would just say build a bunch of small projects of increasing levels of complexity. This is kind of what I did. And the way that I approached this was I had a lot of Golang code. I'm actually probably more comfortable in Rust now than I am with Golang, just because I haven't really worked too much with Golang in the past year and a half that I've been a Rust developer. So my Golang knowledge feels a little bit rusty, but at the time, you know, when I got this job and I started to work with Rust on my like day-to-day basis, I had like a lot of Golang projects that I created when I was learning Golang, like, you know, 4 or 5 years ago. And it just kind of had like a bunch of projects that were like going from small to medium to big. And I actually just, I hope your jaw doesn't drop, but like, yeah, it was a huge amount of effort, but it was the best thing that I did was to rewrite every single one of those programs in Rust. Because I had familiarity with the code, right? So if you have some programs in another language that you are like really comfortable with, and you remember what it was like to develop those programs, I feel like you learn a lot about the language by just rewriting an entire program or an entire piece of a program. You know, just take one aspect of the program, like for example, like I need a program which returns me a random hash based on a specific input entropy. So it takes a string, returns a hash based on that string. The hash needs to have some element of randomness. Or like a uniform distribution of charge set, as we'd say in cryptography. So if you just have like some small programs and rewrite them in Rust, like that was the most useful thing that I did. I know it's very hard, but it's worthwhile. And if that sounds too hard, definitely just read at least the first 5 chapters of the Rust book. The Rust book is written very well. It's very easy to understand. To answer the question of OpenZeppelin in CosmWasm, we do not have OpenZeppelin. We have we have some utilities in CW+. There's also CW utils. I'm not exactly sure what's in utils. I've used CW+ more often. And then we have like the token standards, right? So, you know, we have ERC standards in Ethereum. We have CW standards in CosmWasm. So, you know, like 1155 or like 720. So we have like the token standards. Those are like pretty mature right now. They've been around for a long time. Is this CW 721? You get my drift. But in terms of like someone creating like a dev kit with like a bunch of tools all there with its own set of standards, you know, similar to OpenZeppelin. Like OpenZeppelin is great because it gives you some best practices for your contract development that kind of work right out of the box. But we are kind of one step down, you know, if we're thinking of high level languages going into lower level languages, we're like one step down right now into a slightly lower level of like, we've got all like these packages and we have some utilities. No one's really kind of like strung them together into like a more user-friendly software development that like OpenZeppelin has done. That said, it would be great to see that. And if you want to go and build that, I'm sure I'll contribute to that repository. So let me know. And one more thing, guys, feel free to make pull requests to the Area-52 repo. Let's all build some tests together and get Area-52 into a good spot. I have a lot of new content coming up for Area-52. And I think that, you know, once we have some more tests in place, it's going to be more of a joy to work with Area-52. We're still in our mystery zone where we don't really know right now what the contracts do. No one's deployed them. but we're like really like standing at the precipice right now. We're all about to start teleporting our tokens like crazy. You know, we're very close to this. So help me write tests, make pull requests. We can all build together. Phi Labs, Emmanuel, Adam, you guys have any closing remarks?
No, absolutely fantastic workshop. Thank you, Drew. Thank you for everyone who participated and obviously had a ton of great questions. If you do have any more questions, want to continue on conversation, I shared a link to the Discord. I'll reshare it again. 1 second. Let me pop that in the chat. So please feel free to join our Discord. There'll be many more conversations and opportunity for you to ask Drew and anyone else on the team any questions you have about any upcoming lessons. In terms of scheduling, we're going to do another workshop. We're going to keep the date a little bit quiet for now, but do keep peeled on our Twitter and our Discord for the date for the next workshop. And yeah, we look forward to seeing many more of you on the second workshop. And on that note, thank you everyone for attending. Thank you, Drew, for being an amazing intergalactic instructor and taking everyone through the workshop. And yeah, we'll speak to you soon. Take care. Bye, everyone.
Thanks, everyone. See you at the next workshop.